Hey everybody, welcome to the first episode of Turians Explain. I'm Rear Admiral Doom, and I've started this series mostly just to kind of present a fun way to explain various different subjects. Anyways, I hope you guys really enjoy the video, and please feel free to rate, comment, like, subscribe. Wait, I don't know if there is a rate button anymore. Forget I said rate. But anyways, do your viewer thing at the end of the video, and just please enjoy.
Hello everyone, I'm Professor Solan with the Turian Science Academy, and welcome to class. Today we'll be talking about the light speed constant and interstellar travel. Now, some of you might be asking, what is the light speed constant? Well, c, as it is written in shorthand and known among many astrophysicists, is the essential galactic speed limit. You cannot, under most circumstances, travel faster than c. Now, some of you might be asking, what exactly is c in the form of speed? Well, to put it in ye old Earth terms, c is 186,000 miles per hour. It's also more commonly measured in meters per second as 3 million meters per second. That is the speed of light, also known as c, as previously stated. Now, I did mention there are some exceptions to going faster than c. Those two exceptions are warp, which was mathematically proven to humans by scientist Miguel Alcubierre, and wormholes, which were theorized in the theory of relativity by human scientist Albert Einstein. Now, we'll start with the wormhole because it's simpler. A wormhole is one way you can cheat light speed. Basically, a wormhole throws the principle of the fastest path between 2 points as a straight line. It throws that out the window. Because what a wormhole allows you to do is it takes 2 points of space-time and bends them until they're touching. So therefore, with a wormhole, you can travel between 2 places anywhere in the universe instantaneously. The problems with wormholes, we do know that they occur naturally, but they're very small, and we currently don't know how to manufacture a wormhole, or even how to increase the size of one to swell its aperture. Now, the other method I spoke of, warp. Warp is one of my personal favorites for traveling faster than light. And I know what some of you are already thinking. There's only 2 ways, but what about the mass relays and standard FTL using element 0? Well, I'll get into those here in a minute. But, back to the subject of warp. Warp allows you to move exponentially faster than c by compressing space-time. What you do in warp is you make a bubble around your spaceship, in which the space in front of it is compressed and the space behind the bubble is expanded, essentially allowing you to surf the fabric of the universe at speeds faster than light. And theoretically, you can travel any multiple of c that you wanted. You can travel at c, you can travel at 2c, 3c, 4c, all the way up to infinity. You know, I could travel at googolplex c, but that would be a speed so exponentially fast, I would probably be exerting enough energy to kill the entire universe a googolplex times over. Now, what I was going to say about Element Zero and the relays. To the best of my knowledge, they should not allow us to travel faster than light. From our current understanding of light and of physics, they break those laws. Because making an object massless does not allow it to travel faster than light. Because photons, which are the fundamental particles that transmit light, are massless. Therefore, they cannot, and we already know that photons do not travel any faster than what they already do. So, therefore, if eliminating the mass problem could allow you to travel faster than light, then photons would have a speed that is infinite, which, technically speaking, the velocity of a photon is infinite. But that is a whole other discussion that I'm not really willing to get into. Now, moving on to the subject of subluminal travel, traveling slower than C, which is easily doable. We can travel slower than C with chemical rocket fuel, which is, basically, it's a big duh. I mean, we already do that. Or at least humans did it for, everybody did it for the longest time before we discovered better ways. Now, the problem is, you cannot accelerate to significant speeds using chemical fuel. If you wanted to accelerate to light speed, if you wanted to accelerate to C using chemical fuel, you'd require more chemical fuel than exists mass in the universe. So, you could do it. You would just have to build a ship that has a fuel mass that is many, many times the size of the universe. That is n times the size of the universe. But anyways, some of the problems with just going subluminal instead of, superluminal, sub-C instead of super C, if you will. Subluminal is always going to be slow because it's always slower than C. Even your fastest means of subluminal travel are still going to take you a few years to get there. Case in point, if you were to go 90% of C to reach from Earth to its closest neighbor, Proxima Centauri, it'd take you about 5 or 6 years. And that's going 90% of C. Which we can actually, we, humans and Turians, can actually develop subluminal systems that don't violate the laws of physics, that can get up to that speed, that can get up to 90 to even 95% of C. Now, I'll get into that more towards the end, but I'm going to go through in order of speed the fastest ways to get there. They're the fastest forms of subluminal travel. Now, obviously I mentioned chemical rockets, which are just rubbish. They suck. Now, one thing that's easily doable with modern technology is the Orion drive, which is powered by a series of nuclear detonations. You drop a nuclear bomb out the back of it and detonate it, and you ride the shock wave. Now you detonate these in quick succession, so you have a series of pulses that propel your ship. It's like boom, 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 and it accelerates you. And using this system, you can accelerate up to about 5% C. To put that back into scale, we'll use the Proxima Centauri example again. Using an Orion drive, it would take you 90 years to get from Earth to Proxima Centauri. Now, there is a faster way. There are several ways that are faster, much, much faster. Another way, which we already have the technology for, is a solar sail. Now, mind you, in order to do this, it would have to be an excessively large solar sail, miles in diameter. Kilometers if you're, not using the old Earth imperial system. It'd have to be kilometers in diameter. And what solar sails do is they achieve propulsion by essentially riding the photon pressure from a star. In Earth's case, it would be the sun, or Sol, as it's known in astronomical terms. Now, the problem with solar sails, photon pressure decreases the farther you get away from the star. So the farther it gets away from Sol, the slower the less acceleration it's getting. Now there is a workaround. You can fire a beam of concentrated protons, or not protons, you can fire a beam of concentrated photons at a solar sail to increase its speed, and it can get up to 10 to 15% C. It could get to Alpha Centauri, no, not Alpha, Proxima. Proxima's the closest. It could get to Proxima Centauri in about 35 to 45 years, which is within a human lifetime. Mind you, even the younger people on that vessel would be much older by the time they got there. It's within a human lifetime. So we could load it up with more than it is within a human lifetime. So you could load it up with more than enough people to establish a colony long term on Proxima Centauri. The only thing is, as soon as we knew there was a habitable planet in Proxima Centauri, there would have to be a supply ship sent, if it didn't already bring supplies with it. Well, actually, no, there would have to be a supply ship sent. So we'd have to build 2 ships, launch one, keep the other one in orbit, and then launch it as soon as you got there. And that's if we went to Proxima Centauri from Earth. Mind you, I don't know exactly where Proxima Centauri is, but if the Turians were just to do it by themselves, it may and or may not be closer. No, never mind. Proxima Centauri is definitely not closer to Palaven than Earth. It is much, much farther away from Palaven. But that's besides the point. Right, next on the list, which this is my personal favorite, and this is the last one we're going to talk about today. I might go back on this subject and touch up on some more theoretical concepts later as I come across them, but this is the antimatter drive, and I think that all of a civilization's resources should be pooled into figuring out how to make this system work flawlessly. Because an antimatter drive requires very little fuel because of how violently reactive antimatter is, and how much force it can produce, and how much thrust force it can produce, how much delta V an antimatter drive could produce. Which delta V is a measurement of your change in velocity, both total spent and total potential, and that's a whole nother subject, and that will actually probably be the next thing I talk about in the next video. But anyways, an antimatter engine can accelerate to 95% C. And we can manufacture antimatter in particle accelerators. It's very expensive. We don't necessarily have a very good technology for storing large quantities, but you wouldn't need a whole lot. The old human space shuttles could be propelled, just the shuttle could be propelled into an orbit around Earth with a tablespoon of antimatter. But anyways, drawbacks of an antimatter drive. At 95% C, the amount of force, if you impacted even the smallest of objects, could completely destroy your vessel, killing everyone on board. You would be dead if you hit something the size of a grain of salt. Other drawbacks include antimatter explosions release large amounts of gamma rays, which are lethal to most life forms on Earth, and just in the galaxy at large. So, without proper radiation shielding technologies, which may and or may not be outside the scope of our current technologies, you would kill the crew almost as soon as your engine started. Now, another problem, this relates back to the speed and impacting stuff. Current technologies, including kinetic barriers that the Hierarchy has developed, cannot protect you from collisions. Cannot really protect you from sustained collisions at that speed, which there would most definitely be. So the shielding is beyond the scope of our technology right now, but it could be researched. Another drawback, which goes into the gamma rays, as you enter a system, you could potentially, with the amount of gamma rays, as you come into orbit around a planet, bathe it in lethal amounts of radiation, make it uninhabitable for several years. But anyways, that's really all I have for you today on the subject of interstellar travel, and